Welcome to the Mexborough and Swinton Astronomy Society webinar. This evening we have one of our well-known members, who most of you will know better than me, as you see his face every week while we're doing this. So, Roy has a degree in physics from the University of Bradford, Master of Science in Engineering, and later worked as an IT manager for Sheffield Hallam University at Salter Lane, which was the art college, before it was knocked down. After working for over 30 years at Sheffield Hallam University, Roy has now settled down to a busier life as a retired person. A prolific speaker for Probus, UA3 and WI groups, as well as many astronomical societies. So please give him the Mexborough and Swinton Astronomical Society welcome, and please, I will hand you over to Roy Gunson. Thank you, Roy.
Share the screen. Can we see that?
We've still got your, yes we can, but we haven't started the, that's it.
That's it, we're in business, we're in business. Whoops, it's gone to slide 2 without me asking to. Okay, back to the beginning. Right, we're going to look at basically the history of observing Mars through the ages and taking us right up to the modern day with the space program and many of the space missions that we've currently got. We've been observing Mars for thousands of years. It's always had a bit of an element of mystery about it. At times, it's the fourth brightest object in the night sky. Only Venus, the Moon and the Sun surpassing it, and that's the case at the moment. It's also the planet with the largest retrograde motion in the sky, meaning it goes backwards. And this is always around the time of its opposition, when it's at the closest point in its orbit to Earth. And this retrograde period can last 2 to 2.5 months, depending on the condition Mars is in its orbit. But Paul was saying about up-to-date events. Well, I'm going to take you back at least 5,000 years to Mesopotamia, around about 2,500 BC, to some of the Sumerian civilizations based around the city of Ur, which you can see on the little map there, close to the Persian Gulf. And they, like a lot of these ancient civilizations, had lots of gods and deities who were associated with signs and stars and planets, and the name Nergal appears associated with the planet Mars. And the god Nergal is also associated with war and death, and this becomes a thing with Mars, the god of war. It looks like religion and the idea of Mars being the god of war spread out from this area. Nergal's mentioned in the Hebrew Bible, the Old Testament. If you've got a Bible, go to 2 Kings, and the quotation there is, "And the men of Babylon made Succoth Benoth, and the men of Cuth made Nergal." And on the map there you can see the city of Cuth, northeast of Babylon. The British Museum, in its wisdom, particularly in the 19th century, took lots of artifacts from the Middle East, Egyptian tombs and mummies and Cleopatra's needle. They also brought something called the Mul-Appin tablet, and you can see that on the left-hand side. And it's a cuneiform history of the night sky. It's basically measurements that the Babylonian civilizations made over hundreds of years. Parts of it have been dated to about 1370 BC, though it's believed the tablet itself was written round about 700 BC. In respect to Mars, what it notes is what we call the cyanotic cycles. The cyanotic cycles are the regular appearance of Mars in its orbit in relation to the Earth. Opposition to opposition is a cyanotic cycle. And for Mars, it's a little over 2 years. But what the Babylonians were interested in were 15, 47 and 79-year periods. There's a little map of the solar system. You can see, move my counter, there's Earth moving around the sun, and Mars is here. And every now and again, the Earth catches up with Mars and we have opposition, like there. And then the Earth goes moving off. Mars trundles along a bit slower, following Kepler's laws. Earth gets back to the bottom, but Mars has moved on there. And it takes it 2 and a bit years to actually catch up with Mars. What the Babylonians noticed was that after 7 cyanotic periods, or 15 years, Mars is actually in the same position in the sky. 7 cyanotic periods brings Mars back, so the opposition would be in the same constellation, in the same part of the sky. Same with 15 cyanotic periods, which is 32 years. Mars is, within a week, 0.025 of a year, in the same part of the sky. And 37 cyanotic periods, it's 79.01 years. So that's about 3.5 days difference for Mars being in the same position in the sky. And they noted this. This meant that they must have taken measurements of Mars over quite a considerable period of time to do these calculations. They never worked out the 59 cyanotic periods for 126 years, which would have been an even closer match to Mars being in the same position in the sky. But we'll find out later on that actually our positions actually move a bit. It's not a regular 790 days or 2.135, mainly because Mars has an eccentric orbit. So it's closer to sort of sometimes it's perihelion and the aphelion, and the eccentricity of the orbit is about 10% for Mars. And this makes a difference. Moving on, Egyptians, they took lots of measurements of the night sky. They were particularly interested in things like Sirius and Orion because that denoted when the Nile was going to flood. But they've came across, the archaeologists, a tomb called Senenmut's tomb. And on the roof of this tomb is what they know is astronomical diagrams, measurements of the night sky. And one of these diagrams actually relates to a date in 1536 BC. And what I've put up here is a stellarium screen grab of that date. This is the 5th of May. It says minus 1535. That's because stellarium doesn't have, it has a year 0, but a calendar doesn't. It goes from 1 BC to 1 AD. There's no year 0 on the calendar. So stellarium doesn't think of that. So 1536 BC is actually minus 1535 in stellarium. But what we have in the east rising is Mercury, Saturn, Jupiter and Venus, which is a nice conjunction. No Mars. Mars is actually setting in the west at the exact same time that these 4 planets are rising in the east. And apparently on this panel is a panel, it says the 4 planets, Jupiter, Saturn, Mercury and Venus are easily recognizable. I can't. And the planet Mars is not included in the grouping and at first sight seems to be missing. However, one explanation is that Mars is represented as an empty boat in the west. Now that's what the archaeologists have come up with. I've no reason to believe them, but it just indicates that the Egyptians were actually measuring the sky, interested in the planets, and were taking observations of Mars as well as the other planets. We move on to the Greeks, and the Greeks had a god Ares. Might have got the idea of Ares from Babylonians, incorporating the elements of Nergal into Hercules and Ares. Ares is the god of war, and the sign of Mars is symbolized by a spear and a shield. And we use that symbol today in astronomy as a shorthand for Mars. The brightest star in Scorpio, Antares, is also named from a Greek phrase meaning rival of Mars, anti-Ares. And the Greeks have a history of observation of science and notes and the night sky. And in particular, I've got an example of Aristotle. And on the night of 4th of May, 357 BC, Aristotle noted that Mars disappeared behind the moon during an occultation. And again, I've used stellarium to show the date and the time. And here we have Mars. This is when Mars was appearing. This would have been local time around about 8:15. It disappeared just after 7:40 p.m. And so this is, if he'd got a telescope, he could have seen that even better. But it enabled him to determine that the moon was closer than Mars, and that the moon was actually a sphere because it disappeared behind the black part of the moon, the part of the moon in shadow. Ares changed into the Roman Mars, and again, the god of war. Most of the Roman Mars festivals are held in March, which is a month named after him. It's the season in which military campaigning began, and the Roman army could go out and bash some Gauls and Celts and anybody else, Huns, over the head and expand their empire. But what's interesting is that in India, Mangala is a Hindu name for Mars, the red planet. And it's also the god of war, associated with strength, valor, and courage. The Chinese adopted the advent of Mars as a sign of war or battles. And Cariotius was a god of war in the mythology of various Iberian and Celtic tribes previous to Roman occupation. In Norway, Tyr, the one-handed god of justice and war, is equated with Mars. Mangala, the Hindu god, it's the root of the word Mangalavara, or Tuesday, in the Hindu calendar. Tuesday in Greco-Roman and other Roman-type languages is related to Mars. French Mardi, the French Martes. My pronunciation is probably rotten, but Tuesday seemingly was a day based around Mars. Interestingly, Tuesday in English comes from the name of the Norse god Tyr, which is their version of Mars, the war god. The Greek word for Tuesday comes from the day of Ares. Surprisingly also, Tuesday is also associated with Mars for the Japanese and the Koreans. So you've got to think that the idea of Mars and the god of war that started as far as we're aware in Babylonia, spread an awful long way around the world. Leaving behind ancient measurements and ancient myths of Mars and gods, let's talk about some actual observations. So I'm going to come forward 1,000 years or more to a Jewish rabbi, Levi ben Gershon, born in France, 1288. He was a Jewish rabbi, and he invented a thing called a Jacob's staff. You can see a picture of it there on a stamp issued by Israel, I think in about 2009. And it's an early version of a sextant. It's described as a staff 4.5 feet long, about 1 inch wide, with cross pieces perforated to view objects through, and could slide along the staff. With this, he could measure angles between stars and planets, and sort of take the measurements of them in the sky. He used the brightness of Mars to calculate its distance, and he challenged the epicycles, the Ptolemaic system. He was one of the first scholars in the West to challenge the Ptolemaic system, the geocentric system of the universe. He actually tried to predict how far away the stars were. And when you look at what he wrote, his distance corresponds to something like 100 light years today. So he's got the right scale. I'm not quite sure whether his calculations were actually correct. But he also thought that the Milky Way might have been the reflection of the sun off the celestial sphere. There were similar measurements being done by Islamic scholars of the day. One guy out there had a device very similar to Jacob's staff, but I can't pronounce his name. It's there at the top. I've just popped it up here. I am not going to attempt to pronounce that name. It is ridiculously long. We could call him Alan Miller, I suppose. But he was taking similar measurements of conjunctions of the position of the planets in the sky. He died in 1283. So these were the sort of measurements that were going on at that time in the world. Moving on to a guy called Gervas of Canterbury, a monk, basically a chronicler. He lived in the reign of Richard I and John. He'd been ordained by Thomas Becket. I couldn't find a picture of Gervas, so I'm afraid you got fire truck. He observed a transit of Mars across Jupiter, and you've got to think 1170, 12th of September, for a telescope, because I've done a little video of the occultation of the passage of Mars across Jupiter. Here it goes. So hopefully you can see Mars moving past Europa and Callisto. It approaches Jupiter, and we have the smaller moons, Methys and Thebe and Almathea. Here's Jupiter. For a telescope in Canterbury in 1170. It just passes over the bottom half of Jupiter. Fortunately, Phobos disappears at the same time behind Mars. Mars then gets, and by this time Gervais will have given up, but for an astronomer, I say Mars would have crossed in front of Io, and then eventually it comes across distant Ganymede. And it was set up so it started at 8 p.m. in the evening, this encounter, and finished at 4 a.m. So it would have been a really spectacular night for an astronomer. It's just a shame that we'd only got the naked eye to see this event.
It would have been cloudy.
It would have been cloudy. So Ganymede just sort of goes on the top, but actually Phobos crosses the top of Ganymede. So there we go. That would have been a lovely, lovely sight. There's another occultation of Mars by Venus in 1519. This was observed by this chap. I've not bothered with a video of that because we'd spend all night looking at videos of occultations. There was another Mars-Jupiter occultation in 1387, but unfortunately that was at 1 p.m. in the afternoon. So was probably no good to anybody. The next is going to be in December 22-23, and that's going to be around about sunset. So if you can hang on 200 years, you've got a chance. Mars went across Saturn in 1522, but you would have had to been in America to see that. And the next one is in July 33-32, which is in Argentina. and a lot of the other next occultations. Mars occults Uranus in 3914 and Mars occults Neptune in 2515. So not a lot going. As far as the Venus occultations of Mars, the last one is there at 1590, the next one is 2327. So we've not a lot happening for us, I'm afraid. Moving on, we're still in the era of eyesight observations, and Tycho Brahe was a noted observer of the sky. He was also one of the first people to start looking at the Copernican method model of the solar system, the sun-centered version, and he was taking extreme measurements of all the planets and trying to measure parallax and distance to objects in the night sky. These are just one set of measurements of Tycho Brahe's Mars observations, declinations when it passed the meridian, the southern meridian. He made notes of where things were in the sky. And with these notes and positions that he'd written down, later on, Johannes Kepler, who was Brahe's student, used it to form Kepler's laws, the laws of orbits, the elliptical orbits, the period, the time squared equals the distance cubed, I believe it is, equal triangles. You look up Kepler's law, it's the start of the science of orbits and orbital calculations. Quote there from Kepler: "By the study of the orbit of Mars, we must either arrive at the secrets of astronomy or forever remain in ignorance of them." Because Mars was such a prolific mover in terms of its orbit, the retrograde part, and trying to understand that, it was a very important planet to study in terms of orbital mechanics. But we move on. We move on to Galilei Galilei. He was the chap with the telescope. He was able to determine that the size of Mars changed as he observed it. When it was near opposition, it was very large. When it was basically on the other side of the sun, it was very small. And that helped him formulate the fact that the planets went around the sun. 1610 he wrote, "Unless I am deceiving myself, I believe that I have already seen that it is not perfectly round. Mars does show phases. As a superior planet, it never gets to sort of a half phase, but it does give us phases, and it does show that it is not sometimes completely spherical in the sky." Galileo himself left no record of drawings of his observations of Mars, presumably because it was very tiny in his telescope. I mean, Galileo's telescope was very, very small and had a very small aperture. And the first known sketch of Mars was by Christian Huygens. Lots of people spell his name wrong. Christian Huygens. The Christian bit has double A's in it. That is not a misspelling. That is how his name is spelt. But he made the first known sketch of Mars in 1659. It's this one here. And it's believed to be Syrtis Major, the formation we now call Syrtis Major. He also had an indication of a polar ice cap. He also managed to work out that the rotation of the planet was about 24.5 hours. Cassini. Now, he's famous for the rings of Saturn, the Cassini gap. I mean, he's had a probe named after him. 1625 to 1712. These are his drawings of Mars. I'm not quite sure what he was on to get these sort of drawings. Some are very say he's got one here with 4 ice caps by the look of it. This has got a smiley face. I'm not sure, but he drew these in 1666. This has got 2 eyes. Really, as far as anybody can say, I mean, it bears no resemblance to what we know of Mars. So his instrument must have been weird. However, he did calculate a rotational period of 24 hours, 40 minutes. You could argue that he had noted the presence of ice caps. With a colleague, Jean Richer, Cassini was in Paris and Jean Richer was in French Guiana, and he determined its distance to Earth through parallax. He got it within 7% of the actual distance, so not a bad attempt. I mean, this is, you're looking at 1669. Giacomo Miraldi, born in 1665, he was Cassini's nephew. And for about 20 years, he studied Mars extensively. One of the discoveries that he made was the fact that the ice caps on Mars are not exactly on the rotational poles of the body. He made 3 drawings of Mars during the 1704 opposition. This is one of his drawings, which is, again, obviously Syrtis Major. We've got an indication of an ice cap up the top. And what he was interested in is the rotation of Mars, and here you can see different motions of the Mars, and you can see some feature he's observing is moving to the right. Miraldi is also famous or infamous in terms of astronomy. He was the first person who determined that the corona visible during a solar eclipse actually belongs to the sun and not the moon. The great Sir William Herschel, as far as the UK is concerned, the guy who discovered Uranus, he determined the axial tilt to be 30 degrees. The actual tilt's about 25 and a bit degrees. He thought the dark areas on Mars were oceans and the lighter regions land, and he noted the changing appearance of the polar caps. This is the only picture I can find of Herschel's drawings of Mars, and I must admit it looks like he got bored one night and made just a squiggle down the middle of Mars. I don't think it means anything. He did look at Mars passing close to stars and look at the effect of brightness Mars had to test how thick its atmosphere was. And he did come up with the conclusion that Mars had a very thin or no atmosphere at all. And we've moved right on up now to the 19th century. Wilhelm Beer and Johann von Maedler, and they actually determined the rotational period of Mars to be 24 hours, 37 minutes, 22.6 seconds, which is only a tenth of a second away from the current value, which is 24 hours, 37 minutes, 22.7 seconds. So that's not bad going. You know, they must have been taking lots and lots of measurements over quite a long period of time. In 1830, Beer and Maedler created the first globe of the planet Mars. I can't find any images of that globe, whether it still exists or not, but I have found there, you can see between them, some diagrams which are supposed to represent what the globe looked like from the north and the south. The drawings of Mars there were made by Maedler. Richard Anthony Proctor is the next chap on my observation list. He lived 1837 to 1888. He was a journalist, author, amateur scientist. Lots of these Victorians were amateur scientists. He became secretary of the Royal Astronomical Society in 1872, and he actually worked out the sidereal period of Mars to within 5/100ths of a second. And you can see there on the screen, there's Proctor's value, and there's our modern day value. And you know, to be honest, it's extremely close. I mean, it's ridiculously close. William Rutter Dawes, the chap at the bottom, he was a clergyman. He was born in 1799, died in 1868, and probably, as with most Victorians at the time, the second brother, the second eldest. He wasn't going to inherit the title, so he became a clergyman, but was relatively well off. So he took up the hobby of astronomy as well. Apparently had a nickname called Eagle Eye, and he set up a private observatory in Haddenham in Buckinghamshire. He had an 8-inch refractor. His telescope is still in use today at Cambridge University, and is used by the Cambridge University Student Astronomical Society in their observatory there. It's known as something called the Thorogood telescope. And Dawes made extensive drawings of Mars during its 1864 opposition, and with Dawes and Proctor produced maps together and also a globe. These are still currently in the Science Museum. Their choice of the zero meridian on Mars is still the currently accepted convention. This is Dawes's map. We'd like to nail things because we've got the Dawes continent and the Dawes ocean. We've got the Maidler continent, Cassini land, Lockyer land, Laplace land. So Secchi continent, all named after famous astronomers. We've got the Hook Sea, Kepler land. So he liked to name things. We have none of these names left, apart from the Meridian. Asaph Hall, American, US Naval Observatory, and he discovered the moons of Mars in 1877 with the help of his wife. His wife, Angeline, born with the surname Stickney, and she was a mathematician. She encouraged him to search for the Martian moons, and Hall wrote in his diary, "The chance of finding the satellite appeared to be very slight, so that I might have abandoned the search had it not been for the encouragement of my wife." Deimos was found on the 12th of August 1877 and was seen again on the 16th of August. Phobos was first seen on the 17th, and further observations were made on the 18th to confirm the sightings, and then he sort of announced it to the world. His wife, Angeline Stickney, is immortalised by the crater, this crater here, on the leading edge of Phobos, and that's called the Stickney crater. Then we come to this chap, love him or hate him. He's responsible for what became the Canals, even though he didn't actually believe in them. Giovanni Schiaparelli, he made some observations of Mars, and he observed linear structures on the surface of Mars, which he called canali in Italian, meaning channels. But this term was mistranslated as canals. He was a prolific astronomer. He did a lot of work on binary stars, trying to determine periods of orbit. He also discovered an asteroid, Hesperia, And he also demonstrated that meteor showers were associated with comets and proved that the orbit of the Leonid meteor shower coincided with the comet Tempel-Tuttle. But unfortunately, he's going to be forever remembered as the man who, in quotes, invented the canals. And as a result, this guy picked up the baton, Percival Lowell. He started life as the Foreign Secretary for the US government in Japan and Korea. He travelled extensively in the Far East on behalf of the US government and didn't actually move back to the United States till about 1892. And he basically retired. He got plenty of money. He became determined to study Mars and astronomy. He'd obviously heard about the Canali of Schiaparelli and decided that he would build an observatory using what wealth and influence he'd got, and he founded the observatory which bears his name, and he promoted the idea of a Martian civilization and canals until his death. The Lowell Observatory, as a lot of you will know, is also connected to the discovery of Pluto. Lowell wrote plenty of books regarding Mars, and here we have a typical advert. This appears in November 1896 in the British newspapers. Mars by Percival Lowell, fellow American Academy member, Royal Asiatic Society, Great Britain and Ireland. Has 24 plates and it'll cost you 12 shillings and 6 pence. The book is written in a style suitable for the general reader, and most recent speculation as the planet being inhabited, the possible canals, etc. are discussed. The results of Mr. Lowell's systematic and patient observations are entitled "To the attentive consideration of astronomers and men of science generally is beyond dispute, the Times." So he's written this book. It's quite a popular book at the time, and was this an inspiration for what came next? Because this is part of his book. He's sort of got an irrigation system. He's worked out how the Martians are going to irrigate the land with collecting reservoirs and service reservoirs and irrigation pipes. He's done quite well from a few vague lines on the planet. But as I say, is this in relation to what happens next? Because we get a Mr. H.G. Wells, who writes basically one of the best science fiction invasion stories ever. It's still being used today, fairly badly. I mean, the 1953 film's poor. I thought Tom Cruise's version wasn't very good in 2005. And recently we've had a BBC series which has been panned ruthlessly in the press as being very poor. And also there's a Fox TV series called War of the Worlds done with in association with the French TV, and that's not very good either. So compared to the original novel, which I still think is an excellent story, those sort of ideas are fairly poor. I must admit, I do enjoy Jeff Wayne's musical War of the Worlds. I've been to see that twice, and I really enjoy that. But moving on, we're not done with the Martians and etc. Nicholas Tesla gets into the act, and in the newspapers in 1901 we have Tesla saying, "I am confident that the inhabitants of Mars are trying to signal this Earth." He's got 3 distinct, though faint, movements, one after another, that were observed not once but many times. So he's convinced that the inhabitants of Mars are going to come and get us. The Daily Mail, it was in existence in 1901, and it sought the opinion of Mr. Marconi on Mr. Tesla's experiments. And Mr. Marconi gave the following reply: in early experiments before my apparatus was perfected, I often received signals from apparently from nowhere, this undoubtedly from atmospheric electricity. I should attribute the alleged signals to local disturbances in the atmosphere. And then further down we have a Professor Fleming of University College laughed at the idea of communicating with the people of Mars. He says, I am afraid that Mr. Tesla is led away by his own imagination. So basically he's being laughed at. We've got another interview with Nicholas Tesla. Mr. Nicholas Tesla has given a hint of the nature of the wonderful discovery made by him while carrying on a series of electrical experiments in Colorado. Tesla observed in a certain instrument repeated faint movements for which it was impossible to account. He was led to believe that they were due to currents from the planets, and he now thinks with improved apparatus it will be quite possible to communicate with their inhabitants. Whether he actually succeeded in talking to any Martians is up for debate, but obviously he didn't. So we'll get back to some real observations. This chap here was probably one of the best visual observers of Mars in the early part of the 20th century. Eugene Michael Antoniadi, born in 1870 in Istanbul, died in 1944, spent most of his life in France. He became a fellow of the Royal Astronomical Society in London in 1899, and in 1890 he was one of the founding members of the British Astronomical Association, BAA. He joined the Mars section in 1892 and became the director of the Mars section in 1896. In 1909, opposition of Mars, he came to the conclusion that the canals were just an optical illusion. This is one of his drawings from 1909. He went on to better drawings. This is one of his drawings from 1924. And we can see nice shading. I mean, it's very, very artistic. Syrtis Major, the Hourglass Sea, the great V-shaped mark below centre, Dawes Fort Bay. He's got the pole cap. And if we compare that to photographs, that's a photograph from the Lick Observatory in 1939, 15 years later. I think it's the same region. We've got this area here, which I think is that. This is probably Syrtis Major around here. It's hard to tell. I mean, it's very blotchy, very blurred. We've got a polar clap we can see, but it's very hard to determine. These are, again, the best photographs. This is Lowell Observatory in 1950s. Quite poor. I think this again is Syrtis Major. This area with the two spikes down. Hellas Basin up here. And if you now compare it with this photograph here on the left, it's almost the same area. Here we've got Syrtis Major here, there. We've got this feature here, there. Hellas Basin is here. This photograph was taken in September 2020 by Damien Peach. I removed the colour and made it grey in comparison. Antoniadi's drawing, I think, actually compares magnificently with Damien's photograph. But we're going back to the radio messages. Now, we remember back in 1901, Marconi was taking the mickey out of Tesla. Well, in 1921, Marconi claimed to hear signals that he thought he might be from Mars. And he attempted to listen out in 1924 when Mars was again in opposition. He got his boat, the Elettra, and he sailed that out into the Atlantic Ocean to far away from the coast, so he could listen out for faint signals. He also managed to persuade the American government to listen out. This is a telegram from Curtis Wilbur, the Secretary of the US Navy, and it says, the Navy desires cooperate to astronomers who believe possible that Mars may attempt communication by radio waves with this planet while they are near together. All shore radio stations will especially note and report any electrical phenomenon, unusual character, and will cover as wide band frequencies as possible. From 2400 August 21st to 2400 August the 24th, without interfering with normal traffic. Signed, Secretary of the Navy, Washington, DC. So they're being quite serious about listening for signals from Mars. Of course, they didn't see any, but it's just surprising how Marconi, from 20 years earlier, was taking the mickey out of Tesla to actually doing the same thing. I suspect there was some rivalry as to whose radio wireless system was going to be incorporated, and Marconi won out. We're moving forward again. We're still looking at this idea of canals and Martians, and mass panic caused by broadcast in the United States. War of the Worlds taken as true. Fear-stricken listeners pray. I've picked a really nice newspaper. It's the Yorkshire Post. So we've got some local news there. I was quite interested in the balloon barrage for Sheffield. And very typically a Leeds nightclub, the people come out and they have a fight with the police at 4 o'clock in the morning. It's also reported in proper newspapers. In the Observer, we've got Mars invasion hysteria in the US. H.G. Wells demand a full retraction. So the idea is in the public conscience that there are Martians, there's canals, there's things living on Mars. Second World War breaks things up quite a lot, and so we're moving on towards basically the space age. Now we have a map here, and this is still very reminiscent of Percival Lowell's Canals map. It's got straight lines, it's got blobs that might be cities, might be oases. You've got current names, Hellas Basin, you've got Arcadia, Cydonia. These are the names that the International Astronomical Union have put on Mars. This is the map they use. This is a map that NASA adopted in 1960 when it was planning its Mars probes, the Mariner series. This was the best that we'd got. And as I say, what's striking about this map is we still have the channels, we still have the canals, the channels, the straight lines, which there are great suspicions that they are just an optical effect, which we now know they are. But the chances of anything coming from Earth, as the song goes, 1960. The Russians start trying to send things to Mars. Between 1960 and 1962, there were 5 failed Russian attempts to send a flyby to photograph Mars. 4 were launch failures, 1 got halfway and died. USA sent up Mariner 3. In 1964, it failed, but the Americans were actually duplicating missions, so at the same time they launched Mariner 4, and that was a success. It achieved a flyby in July 65 and brought back the first photographs of the Martian surface. And they were disappointing. They were cratered. Mars was just like the moon. There are no canals. There was no cities, there was no Martian civilization. All, unfortunately, the path of Mariner 4 just went over the highlands of Mars. It just showed you the craters and the rough ground. It didn't show you any of what we now know are the more interesting features. The Russians failed twice again before Mariner 6 and Mariner 7 flew past in 1969. And what did they see? Yet more craters. Again, it was a bit of a disappointment, but there was an inkling there were other things going on. We'd got shadows, wind-blown shadows across the surface. We'd got what looked like some sand dunes building up. So it was looking slightly more interesting, but it was a very much cratered surface that we saw. America had failures with Mariner 8 and other Russian missions failed before 1971 saw a flurry of missions. Mariner 9 arrived in November 71. The Russian probes Mars 2 and Mars 3 arrived in December 71. The Russians had landers, but they failed. They just crashed. Unfortunately, Mars had a global dust storm, and not a lot could be seen. This is one of the pictures that Mars 2 took, and you see just basically a featureless globe. Mariner 9 had beaten the Russians to Mars by a month, but the Americans were able to delay taking pictures until the atmosphere had cleared. It just shows you the difference in the technology. Between Mars 2 and 3, they were only able to take 60 pictures. Mariner 9 ended up taking 7,329 images before it finished in October 1972. But what we got from Mariner 9 was this. We got some really spectacular stuff. The idea that Mars was not like the moon. It was different. It was a volcano. There was riverbeds, and there was the biggest canyon that's now named after Mariner 9, Valles Marineris. There are some wonderful things that we saw. Russians fail again with Mars 4 and then Mars 5, 6 and 7 before the Americans got the Viking orbiters and landers in 1976. Both landers lasted for over 3 years on the surface. And this is a picture taken by Viking II on the surface. What's notable is it took a panorama, 180 degree panorama. This is the start point and this is the finish. It started early in the morning and you've got this frost. When it got back again, the frost had evaporated mainly. It's thought that this frost might actually be carbon dioxide frost, not water frost. But it just showed, and it showed to the scientists back at home that there are changes on the Martian surface. We can see here the trench that the Viking took that gave those strange results of non-life, the chemical reaction that got everybody excited for a few days, but turned out to be just a chemical reaction. After Viking, the Russians failed again with Phobos 1 and 2, and America failed with Mars Observer in '92. But then we got some real successes. I've just listed them. We've got 1996, Mars Global Surveyor, spent 7 years in orbit. Mars Pathfinder and Sojourner, 6 months on the surface. The first rover there, Sojourner. Mars Odyssey, still operational. It's still there. It's still taking photographs. 2003, European Space Agency sent Mars Express. That is still operational, still in orbit, still taking photographs. 2003, the Spirit and Opportunity rovers. I still think Opportunity is probably one of the best missions that we've sent to Mars. Opportunity covered 24 miles, spent 10 years roving the surface. It sent back 187,000 images during its lifetime on the surface of Mars. That is an incredible amount of information. Mars reconnaissance, still in orbit, 14 and a half years in orbit, 387 terabits of data, 250,000 images. The amount of information and pictures of the planet Mars we are getting is tremendous. We had the Phoenix lander. The Curiosity rover, still operational. India has got a Mars orbiter, sent in 2014, still operational. The Maven project, looking at gases, still operational. ExoMars, European Space Agency, we've got the orbiter work, the lander crashed, the orbiter is still operational. There's going to be a follow-up in about 2 years' time. And in 2018, the InSight lander with the seismograph to look at the Mars quakes, and that's still bringing back results. So we're still going. I've deliberately ignored Beagle. That went with Mars Express. That was a disappointment, really, for Britain. What's for the future? Well, on the way currently, launched back in July, a mission from United Arab Emirates, the Emirates Mars mission. The Chinese have got an orbiter lander rover combo, groups of Mars, and NASA have got the Perseverance rover, which contains a helicopter of all things, going to Mars. They're all due to arrive February 2021, so after the new year. We should start to get some information back from these. Whether the Chinese will launch a lot of information or the Emirates, I'm not quite sure. It's very difficult to find information off the Chinese, off their space program. ESA are going to launch the second part of the ExoMars, September 2022, and that's planned to have an orbiter, lander and a rover. The picture below, which is supposedly the ExoMars project. So, today, we talked earlier about Mars and its cyanotic period, 2 years plus. Where we are at the moment, this is where we are at the moment, October the 13th, 2020, so we're just past opposition. The distance is 38.6 million miles. We can see the difference in the orbit. The black circle is the Martian orbit, the white circle is the Earth orbit. Here, there's perihelion for Mars, so we're closer to the Mars at that point, and then further away, and it's almost 2 to 1. So at the distance here, it's 63 million miles. Here at perihelion, it's about 34. So it's almost 2 to 1. Oppositions occur in August, are favourable in the sense that Mars is the biggest. For us here in the Northern Hemisphere, unfortunately, it means Mars is low down. It's squatting on the horizon. October, November oppositions, which occur around this period, part of the cycle at the moment, are probably the best for us in the Northern Hemisphere. If you look at the size, the very close opposition in 2003, the size was 25.1 arc seconds, and that is a representation of how big it was. 2012, it was at one of its most distant oppositions. It was 62 and a bit million miles away, and in comparison, it was that big. This is the size of Mars for this opposition. Now, I mentioned before, the orbit of Mars is slightly skewed. It's got a high eccentricity. So the maximum size doesn't always occur at the date of opposition. So here, the date of it's only a day apart. For this one here, it was actually closest to us on October the 6th, even though opposition wasn't till October the 13th. So there was quite a disparity. There was a week's difference between the two events. And because of this disparity of the orbit, the eccentricity, the 790-day period, cyanotic period, only really applies if the two orbits of the Earth and Mars are circular. But because they are ellipses, there is variation. So the days from the previous opposition is as thus. So 2003 to 2005, it was an 802-day distance. The current one, October the 13th, were 809 days since the previous one in July 2018. And we're going to have to wait 786, a shorter period, before we get the next one, December 2022. And that is due to the path of Mars, to the orbit of Mars being so eccentric. That cyanotic period moves up and down. So there's a picture of Mars from Damien Peach again. He took this on October the 7th when Mars was just about at its closest to Earth at 35.8 million miles. Nice picture. And what I'm going to do, finish off with, is some images from Mars from some of those space missions from the past, present, and what's going on at the moment. So here's an image I think is quite unusual. It's Mars taken by the Indian Mars orbiter, Mangalyaan, named after that Hindu god. It's taken in 2015. That's the North Pole, and I think it's an unusual view of Mars, of the planet. You're looking at the pole. Here, July 1997, Pathfinder photographs the little Sojourner rover. Now, I think many of you have probably seen the film with Matt Damon, The Martian, playing Mark Watney, where Mark Watney goes and rescues Pathfinder and Sojourner in the Martian desert, and he has to dig it out of a sand dune. Well, I'm afraid that where Pathfinder and Sojourner landed, I don't think there's much chance of it being buried in a sand dune. It might get hit by a rock, but it's not very sand duney there for it to get buried in windblown sand. Viking orbiter, so 1978, a glorious picture of Olympus Mons. You see the craters at the top, the vents. The largest volcano in the solar system. Mars Reconnaissance Orbiter, sometime between July 2010 and May 2012, a meteorite hit the Martian surface. They noted the difference and change in the surface, and so a more detailed photograph of the surface was taken in November 2013. This is a crater. This is a fresh crater. It's about 100 feet across, and I think obviously that NASA scientists love doing a bit of false colouring. I'm sure it's not quite that blue, but all in all, it's a very dramatic picture. Great things, great pictures. We can go to the South Pole, and one of our members, Peter, gave a talk on the spiders of Mars. So here's a photograph of the spiders of Mars. Carbon dioxide ice evaporates as it warms up. It brings out dark material that's contained with it in the geysers that erupts, the carbon dioxide geysers, and we get this sort of strange terrain, which are called the spiders of Mars, with reference to David Bowie, I suppose. As I say, one of my favourite missions was the Opportunity rover. I mean, 24 miles and 15 years across the surface. July 2014, Opportunity approached what's now called the Lunar Cod 2 crater. It's about 20 feet across. It's a fairly new crater, fairly recent crater. There's no real estimation of the Earth, but just beyond it is an ancient crater, which is just really a depression in the surface of the similar size. Again, it's compared to the Viking terrain and the Pathfinder terrain. This is almost Lawrence of Arabia country. Again, Opportunity took this photograph on the lip of Victoria crater. This was in 2007. You know, you get cliffs like that at Ravenscar and at Whitby and Flamborough Head. You know, you could almost be there. And I mean, this waves down here could be the sea. It's actually sand dunes, but you know, it's very evocative of that type of view. And down in Opportunity went into a crater called Endurance Crater, and these are the sand dunes. Again, I'm sure NASA's tinkered with the colour balance, but I mean, it does make for a spectacular photograph. Mars Odyssey. This is again a crater in Utopia Planitia. I think again some glorious photographs. And to finish off with, this is a recent picture taken by the European Space Agency Mars Express, a region called the Meridian Mountains. They released it on the 3rd of September 2020. But what I like about this is on these hills, you've got these water channels, river channels. To me, they're very reminiscent of the type of markings you get on hillsides in the Peak District. Obviously, some flows come out of this crater. It's broken the crater wall and flowed down here. You've got this dark sand and the sand dunes here, which has broken into this crater here. You know, and quite extensive river course there. I think that's just a marvellous photograph. Oh, sorry, I've got some more. I thought I'd finished. This is, again, from Mars Express. It's Valles Marineris, and it's got a high-resolution stereo camera that can point sideways, so you get an oblique view, and you can see mist in the bottom of the canyon. And yes, now we're finishing off with the Curiosity. It's got a mass cam and it takes pictures in its Gale crater, but you can see the rock, sedimentary rock, the layers laid down over long periods of time, probably millions of years, while there was water, liquid water on the surface of Mars. And here's another picture of the same sort of thing. You can see the layers of sediment that's laid down. But what's also interesting on there's this white material that's seeped up. Was that from some sort of volcanic event? I can find no reference to why there's this white stuff going up there. That was Curiosity taken on 2017, September. And Curiosity also took a video of a dust devil. I think that's marvellous, that dust devil. Weather on Mars. The actual event lasted 4 minutes longer. They speeded up the frame rate just to show it moving. And so, thanks for listening. And one day we may be going to Mars with SpaceX as a tourist. Thank you very much. And we should be back live.
Thank you, Roy. So, if I can cancel your spotlight and go back to gallery view. And welcome back, everybody. Thank you very much, Roy. So Tesla and Marconi were at each other's throats.
It looks like it, doesn't it? I mean, very much the 1901, Marconi is taking the mickey out of Tesla, and then, well, they were competing. They're in a competition for whose system was going to work. I mean, Tesla was fighting Marconi. He was also fighting Edison over light bulbs as well. And Tesla seems to have lost out quite a lot of the contracts. And then gets to 1921 and Marconi, I can hear things from Mars. It's publicity. I think it is little more than publicity on both accounts.
So you don't think the message was so long and thanks for all the fish?
Not quite, no.
I'm just wondering. Okay, so I am looking for questions. Hands up or raise a digital hand, please. Anybody got any questions or comments, etc.? I don't see any. Oh, hold on. Phil Moffat, can you unmute your microphone, please?
Yeah, Paul. Hi, Paul. Sorry, I dropped in late. I don't know if you discussed this earlier, but it's not particularly a question, but more of a comment. Some time ago, I did a bit of work on Mars on the laptop, and I found quite a few VR sites. Well, NASA's got one where I think it's opportunity. You can go on their page, and you can do a virtual walkthrough of the path that it's done. They've like done 3D VR recordings. So if you've got like an Oculus headset or one of these box headsets you can put your phone in, you can actually walk through where the rover's been on the surface of Mars. So it's all encompassing. And also your smartphone, there's a couple of Mars apps you can download. They're a bit more basic, but they're okay for phones, and with a cheap headset for a tenner, you can slot your phone in and you can do a virtual walk around various places on Mars where the landers have been. If you're interested in Mars, it's a really good experience. I'd recommend anybody try it if they've got a VR headset.
Oh, thanks for that, Phil.
You're welcome.
Okay, and I'm still looking for questions. Terry, can you unmute yourself, please? There you go, Terry.
Yeah. Hi, Roy. I thoroughly enjoyed it. It was brilliant. Last year, I had the opportunity of talking on behalf of West Yorkshire Astronomical Society in the Museum of the Moon in Wakefield. And it was in connection with Beagle II and a chap called David Rowntree, who was the drummer with Blur. And I read up quite a bit about it. So for that particular talk, I had a bit of information. So Beagle II, believe it or not, was the only successful one to land first time, but they didn't know that until 15 years later when they found it, because they didn't know where it had got to. So, you know, with that in mind, the sort of Colin Pillinger and the European Space Agency had done an absolute sterling job for £25 million, which were about 1/100th of the cost of all the other Mars missions. And it doesn't seem to get recognised anywhere. They don't talk about it or anything, which is sad.
It's sad. I mean, they've taken the photograph of it down there on the surface, and just that one panel that failed to...
That's right, yeah.
They were so close. They were so close.
Mm-hmm.
Well, that seems to have been the problem, isn't it? That there was a battery on Beagle 2, and the first petal that came out wasn't the antennae. That's
right. It was underneath the last one, I think. So, and that didn't open.
Yeah.
So it never phoned home. It had some Blur music on there that would have signalled that it had landed okay, and all the petals had opened successfully. And sadly, it never happened 3 of them
No.
opened and the last one didn't.
Yeah.
It's a shame.
It's just something that you don't, you can't, well, you can, but it's very difficult to plan for all eventualities. And such an unfortunate eventuality, which finally broke Dr. Colin Pilger, didn't it?
It did.
So
Yeah, it did. Yeah.
it's a very, very sad case.
Okay, thank you.
Thank you, Terry. Anybody else? Andy Devey.
Yeah, just a comment. Very well researched, Roy, and I really enjoyed it. You've put a lot of time into that. First class job.
Thank you.
Thank you, Andy. Roy, in your reading, your historical reading about Mars and looking into other cultures, just out of a matter of interest, did you come across anything from the South American, the Maya?
Yeah, I dropped quite a bit off because I did a practice run yesterday with Eleanor, and it was an hour and a half. And I thought I cut quite. There was the Mayans who there's a thing called the Dresden Codex, which is a book made out of bark leaf. It's called the Dresden Codex because it's in the museum in Dresden. Typical Europeans, we've pinched everything and put it in a museum over here. And that is, the Codex itself is dated round about the 1200s AD. But it notes measurements going back 1,500 years before that. And in particular, it's doing very similar things that the Babylonians did. It's noting the cyanotic period of Mars. And when Mars reappears in the same place in the sky after 15 years. So they're doing the same. There's a place in Guatemala called, I think it's Zoltan, which is a load of pyramids. And apparently on the walls of these pyramids, there's inscriptions relating to astronomical observations.
Okay, can you just repeat your last sentence?
Right, there's a place in Guatemala, I think it's called Zoltan, something like that. It sounds a bit Flash Gordon-y. It's got, there's a load of old temples, and there's inscriptions on astronomical events and charts on the walls in there. And some of these date back quite a few hundred years pre-Columbian.
Just out of a matter of interest, did they make any connection with Mars and the god of war?
No, I tried to find where that had come. I mean, one of the, for me, there was obviously a lot of communication between the Middle East, right? I mean, going through to Britain. I mean, we know, say, the Minoans were trading tin into Cornwall, as far as going as China and Japan. I mean, there is that connection there. Well, we know Alexander, who was, I think, round about 400 BC. I mean, his empire stretched from Greece right through to India. So, I mean, that was a great swathe of land. So there had to be cultural contamination, and this idea of dating back to about, as far as I could research, about 2,900, 2,500 BC, of a god of war. There was two. There was Nergal, and there was a semi-god called Eri, who was pestilence and disease, who seemed to get incorporated into Nergal. I threw a lot of this research away because it got quite convoluted with different civilizations having variants on the same god. I mean, the Egyptians had Horus was assigned to Mars. And he was, that Mars, Horus was supposed to, the path of Mars was the spirit of the pharaoh going through the godly realm, as it were. But the problem with this sort of research is that you go online today and look at the internet, and it's full of rubbish with people who are astrologers, mystic legs, and all sorts of weird stuff, and you try and find the real stuff away from the rubbish chatter, and you know, you have a problem there when you're trying to look at research from an amateur's point of view, trying to research that sort of information.
Okay, thank you for that. I'm looking around for any other questions. No, I can't see anybody who's who needs any more information this evening. So, ladies and gentlemen, can we give Roy a big Mexbrin Swinton thank you for an excellent talk. Thank you, Roy.
Thank you.